Consider the velocity function for an object moving along a line shown in the figure. Describe the motion of the object over the interval 0 to 16. Use geometry to find the displacement of the object between 0 and 2. Use geometry to find the displacement of the object between 2 and 11. And assuming the velocity remains 10 meters per second for 10 greater than or equal to 11, what is the displacement function between t equals 0 and any time t greater than or equal to 11? Okay, so we're given a graph here, and this is the velocity graph. So the first thing you need to know about this is in order to find displacement from a velocity graph, you need to find the area between the curve and the t-axis. Okay, and if that area is above the t-axis, as all of this is, that's positive displacement. We don't have any area below the t-axis in this particular problem. If we did, that would be negative displacement. Okay, so we have all positive displacement on this problem. Okay, so it asks us to describe the motion of this object over the interval 0 to 16. Okay, so the motion on this is that as it's between 0 and 1 right here, the speed is increasing. Okay, it's speeding up because this displacement is becoming more and more, and the velocity graph is increasing. So it goes from a velocity of 0 to a velocity of 30. Okay, and the displacement is rapidly increasing. Okay, and then from 1 to, let's see, what is this, 6, okay, the velocity stays the same. So it's moving at a constant rate. It's much faster than it was, but it's moving at a constant rate of 30 meters per second when it gets up here. And then the velocity starts slowing down between the interval t equals 6 and t equals 11, slows down to 10 meters per second, and then after that it remains constant. Okay, so let's move on to B. Use geometry to find the displacement of the object between t equals 0 and t equals 2. Okay, so t equals 0 and t equals 2. So what we're looking for is the area under the curve here. And what I'm going to do is I'm going to split this up into two sections here. I've got this triangle right here that has a length of 1 and a height of 30. And we know the area of a triangle. So first we do area of the triangle from 0 to 1. Okay, so that is going to be 30 times 1 divided by 2, which is 15. That's the basic area of a triangle, length times width divided by 2. And then we're going to do the area of the rectangle from 1 to 2. So right here, and all the way up to 30. So that area is just going to be 30 times 1 equals 30. So if you add those two together, you get the area under the curve, or the displacement between 0 and 2, is going to be 45 meters. Okay. Let's move to C. Okay, C says use geometry to find the displacement of the object from t equals 2 to t equals 11. Okay, so we have two separate intervals that we're going to split this up into. T equals 2 goes from here to here. That is a rectangle. Okay, so it ends at 6. So we're going to find the area of a rectangle from 2, which is right here, to 6. So the height of that is 30. And the length of that, 6 minus 2, is 4. Okay, so for C, the area of the rectangle from 2 to 6, A, is equal to 30 times 4, which is 120. And that's 120 meters. And then we'll do, and there's a couple different ways of doing this. You can do the trapezoid. That's the way I prefer. Trapezoid, you do the A would be this height, which would be 30. B would be this height, which is 10. The length of the trapezoid would be from 6 to 11, so that's 5. So the area of a trapezoid equals a plus b over 2 times h. Okay, so that's equal to, and this is on the interval 6 to, not 2, 6 to 11. Okay, so we said that that's equal to 30 for height A and 10 for height B over 2 times h, which is, I guess I could have wrote that, let's say 40 over 2 times h, and we said h was this length right here. The interval is from 6 to 11, so times 5. Okay, so that's 20 times 5 equals 100 meters. Okay, so for letter C, we've got 120 meters and we've got 100 meters, so that's equal to 220 meters. Okay, and for part C, or part D rather, it says find the, assuming the velocity remains constant from 10 meters per second, t greater than or equal to 11, what is the displacement function between t equals 0 and any time t greater than or equal to 11? Okay, given that, we know the displacement all the way up to t equals 11. We found A and B. Okay, so the answers to A and B were 220 and 45. So the first thing we need to do for letter D is figure out what the total displacement is leading up to 11. The total displacement was 220 plus 45. So we get 265 meters, and that's the displacement from 0 to 11. Okay, now they're asking us to find a function that represents the displacement between t equals 0 and any time greater than 11. Okay, so the first thing we'll do is we'll have 265, and we'll call this D for displacement. 265 plus, all right, what is the, it looks like it's a constant velocity here of 10. Okay, so we'll say every second after that has a velocity of 10 for every second, and then we're going to say t minus 11 for the, that's because if we plug in a 11 into this, we get t equals 0, or we get the time equals 0. So we're basically ignoring everything that, not really ignoring, but starting here at t equals 11. So if we plug in an 11 into that, this becomes 0, so we get 265. All right, and we already know that that's correct. 265 is the displacement leading all the way up to 11. So if we plug in 11 here, we'll get 265. If we plug in a 12 here, that would be 12 minus 11, which would be 1, which means we'd multiply it by 10, and that would mean that our displacement would be 265 plus 10. Okay, and we can confirm that by saying, okay, well, what's this little displacement right here from 11 to 12? Well, it's 1 times 10, which is 10. Okay, if we plugged in a 13, we would be actually asking what is the displacement added on between 11 and 13, which is 2 times 10, which is 20. So we plugged in a 13 here. 13 minus 11 is 2, times 10 is 20. Okay, so this is our function that represents the additional displacement we would get if we went past 11 all the way to 12, 13, 14, and so on if the graph extends outward. And you can clean that up a little if you want to. So 265 plus 10t minus 110. Okay, so that is 10t plus 155. And that's your displacement function for t greater than or equal to 11.